Let's look into the chain rule under calculus. That's differentiation. The chain rule. Now, why do you have the chain rule? Don't forget from differentiation. If you have y, that's a function of x. If y is a function of x, you understand me now? So from y to x, you can introduce a letter in the middle. That's u. You understand me now? That means going from y to x, you can first of all go from y to u, and then from u to x. That is your dy dx normally that you are looking for, which is from your differentiation dy dx. So my dy dx, so going from y to x, that's dy dx. It means I can go from y to u firstly, that's dy du, and then from u to x, that is du dx. That is my dy dx equals to dy du times du dx. That's a chain. So there's a chain in between y and x, and that is u. So a chain between them, the chain rule. You understand me now? So dy dx equals to what? Equals to dy du times what? Times du dx. Du dx. Hope you get that. So that is the chain rule. So this function is also called a function of function. Function of function. You don't get it? That is, for y to be a function of x, understand me now? We can first of all have y being a function of u, then u being a function of x. So function of another function. Let's say from y to u here, you can have a function f. Then from u to x, you can have a function g. So a function of function. So we call it composite function. You understand me now? Now, you can see that this formula is correct because if you look at it intuitively, if this du cancels the u, we still have dy dx. Again, you can see now. Now, why do we use chain rule? How will the question looks like for us to know that we're going to apply chain rule? Let me explain to you. If you see that you're having a long expression, for an example, if you have y equals to x plus 4 raised power 5, or something like this, y equals to, let's say we have x squared minus 5x plus 6, let's say raised power 4, something like this. Or let's say you have y is equal to exponential raised power x squared plus 5. This, we are going to apply chain rule. This long expression here, that's what you call your letter u. You understand me now? So everything here we call letter u. This everything here we call letter u. Hope you get the point now. So and that's where chain rule, comes from. Now let's take some examples. Let's take one or two examples and let's apply our chain rule for it. Now don't forget to subscribe to my channel to have more of this video. Don't forget to do that. You can kindly do that like that. So let's say we have this kind of question. We have to do something like this. Find dy dx if y is equals to x squared plus 5x plus 6 all raised power of 3. Look at this question here. So obviously we are going to apply chain rule. So this old expression, this long expression, we are going to call it letter u. So let's see, you can say let u to be equal to what? This old expression, x squared plus 5x plus 6. So once you have made this old expression to be u, then that becomes y is equals to u raised power 3. So which means y is equals to u raised power 3. You can see now. So that means for y to be a function of x, this is y to x. So we call it the y dx. So for y to be a function of x, y will first of all be a function of u. That's dy du. Then u will now be a function of x. That's du dx. So that means from here, what we can find here is dy du. And from here, what you can find here is what? Du dx. You can see now. So what you got from your dy du and what you got from your du dx, you multiply together to now get your original dy dx. You can see now. So very simple and easy. So hope you are getting the uh, workings. So let's quickly find our du dx here. Don't forget your general formula. You understand that if you have y is equals to x raised to power n, and you have to find your dy dx. Dy dx. Don't forget your dy dx will be what? Don't forget your n comes down here, n. Then you write your x raised to power n again, x raised to power n. Then you take away 1 from this power minus 1. Don't forget that. And also don't you have to know that the derivative of a constant. Derivative simply means dy dx. When I say derivative, dy dx, you understand me now? So now the derivative of a constant is always zero. Is always zero. Don't forget that, you understand me now? So let's look at it now. So let's follow this same pattern to get our answer. So how do we get du dx here? Du dx equals to the middle. So we have du dx. So we treat it one by one. We deal with this one separately, this separately, separately. So let's see. What will x squared become? Very easy. Just follow the formula I just clean now. This 2 comes down here to write your x squared again, x squared. Then you take away 1 minus 1. You can see now. So of course, this 2 minus 1 is 1. So you can also write 2x power 1. We can just leave it. That's 2x. You can see. So we have what? Plus. Now 5x. Whenever you have ordinary x here, that is not having any power here, just remove the x and write the number here, the coefficient. That's 5 plus 5. You understand me now? Note it. Then 6 is a constant. It doesn't have any x. So it turns to 0 or just goes away. So that's our du dx. So du dx is what? 2x plus 5. Now let's also find our dy du here. So let's see dy du. So let's see dy du is what? Apply the same formula. This 3 come down here. 3. Then write your u. You take away 1 from this 3. 3 minus 1 is what? Is 2. So now that we have gotten our du dx and our dy du, we can now get our original dy dx by applying the chain rule. By the chain rule, we know that dy dx equals to what? Dy du by the chain rule times what? Times du dx. Don't forget that. So let's apply that quickly. So let's apply it quickly. Let me clean this. Hope you are getting it. Okay. So my dy dx now, which implies that my dy dx equals to what? So what do I get to my dy du? My dy du is what? 3 u raised power 2. So we have 3 u raised power 2. You can see times multiplied by what is my du dx? My du dx is what? Is 2x plus 5. 2x plus 5. You can see very easy and simple. So we're going to have what? 3. Don't forget what to call your u from the beginning. Don't forget it. What to call your u. My u is what? Is that x squared plus 5x plus 6. So my u is what? S squared from the beginning. Go and check it. So s squared plus what? Plus 5x plus 6. I'm just returning it there. 3 is 3. My u is this. My square is still my square. Then my 2x plus 5 comes here. 2x plus 5. So this is my answer. That's my dy dx. You can see very easy and simple. So that is the chain rule. So that's the first example. Let me give you more examples on that chain rule. So now you can just choose to, let me just finish. You can just say, okay, you have 3 can multiply this. If you like, you can multiply, or you can just bring it beside it. 2x plus 5 comes here. And I'm going to write this one again, s squared plus 5x plus 6 everything squared. So that is my dy dx. Understood. Now let's take one more example or two. Let's take 1 or 2 examples more. Okay, we are still on the chain rule. Don't forget, we are still on where? On the chain rule. Don't forget that. The chain rule. So let's take one more example under it. One more example. Okay, let's say you have something like this. Find dy dx if y is equals to exponential x sine x. Let's look at this question. Find let me this is not the chain rule. Let me do something like this. Let's look at sine 3x minus 5. Sine 3x minus 5. Yes, so let's look at this one. So sine 3x minus 5. So let's say 3x minus 5. Now let's read what let's see what we're going to do in the solution. Obviously, we are going to apply the chain rule. Why? Because we have this long expression. You can just call it u. You can say let u to be equal to what? This 3x minus 5 minus 5. So this implies that what? Y equals to sine u. Y is equal to sine u. Understand me now? Very easy and simple. Now let me give you, there is something we call standard derivative. Standard derivative. So let me give you now quickly. So you can just put it down. Let's say we have y and we have dy dx. Dy dx means your derivative. So we have standard derivatives. So if your y is sine x, your dy dx is cos x. Just try and master it. Sine turns to cos. If your y is cos x, your dy dx is minus sine x. You have to learn this. Just know that sine and cos are like complements. If you see sine, it changes to cos. If you see cos, it changes to sine with a minus. Don't forget that. So we have taken sine and cos. Let's take tan. If you see tan turns to sec square x, sec square x. I hope you know what sec means. Sec is 1 over cos. When you divide 1 by cos, you get sec. So whenever you see tan x, your divided is what? Sec square x. Don't forget that. Then what about if you have sec itself? If you have sec x, your divided will be sec x tan x, sec x tan x. So please go and note all these. They are standard derivative. What about if your y is cos x? We are going to have minus cosec square x. Cosec is 1 all over sine. Cosec is 1 all over sine. Note that. And the last one is a cosec. The last one is cosec. If you have cosec x, it's going to turn to minus cos x cosec x. So please just try and learn this. Put it down in your notes and learn it later. Put it down in your notes and learn it later. Note that. So now let's continue from where we stop here. So that's what we're going to apply here. Though we still have standard derivative for logarithms function. You understand now? Like if you have exponential x, you can just add it to what I gave before. It also turns to exponential x. Note that. You understand me now? Note it. Now let's continue. So I will note that. Let's apply our chain rule, of course, just like the first example we did. What can we find here? We can find the u, the x here. And what can we find here? We can find the y, the u here. So whatever you got from here and from here, you multiply them together to get your dy, the x. So let's see. So well, we find the u, the x here. The u, the x. So let's see what. Let's look at one by one. Du dx. Take it one by one. 3x turns to 3 like I told you before. If you see your x, if you see ordinary x, just remove and write the letter here. This ordinary number is turns to 0. 3 minus 0, and that is 3. So we have 3 for our du dx. Now, what about dy du? Dy du. Dy du is what? So sine u, just check the table I just gave you. Check the table. Whenever you see sine, it changes to cos. So sine u changes to cos. There is no particular formula for that. Just know the standard derivative to get your answer. So once you have gotten this and this, just apply your chain rule straight up. So by chain rule, we know that dy dx equals to dy du by chain rule. Don't forget that times du dx. Just apply it. We are going to have what? So that means from there we are going to have. So my dy dx is what now? So let's say follow it. What did I get my dy du? My dy du is cos u times what's my du dx? Du dx is 3 times 3. So I can just put 3 in the front here. So that's 3 cos u. And my u from the beginning is what? My u is 3x minus 5. That's my u. Wherever I see u, I put what? 3x minus 5. So that is my answer for my dy dx. So if my y is what? Is that my dy dx gives me this. That's very simple and easy. So let me stop here. I will continue in next class. Don't forget to like my video, comment, and share my video and subscribe to my YouTube channel. Stay connected. Once again, welcome to Mr. Bam's online class. Thank you.